Welcome back, everybody. We're going to be going over 1.5 casting and strings in C++. And to start this off is with a conversation about implicit and explicit casting. Okay, so if we look on the left here, okay, this is going to be an example of implicit casting. Just like when you say someone's implicitly doing something, it's not as obvious that it's happening. And that's exactly what's going on here. So look, we have a 3, which is an integer. And we have a 4.5, which is a double. So an int and a double. Now, normally these things can't work together, and that's where implicit casting is going to happen. Okay, you see that this is storing in an int. So this 4.5 is going to get cut off to be just a 4, right? Because we can't have decimals. So maybe here it might cast this 3 to a double and get 7.5. But then it's just going to cut it off and be stored as a 7, okay? Which is not true of this situation here, okay? Here it might be convert this to a 3.0 plus 4.5 is 7.5, and because we have a double, it won't get cut off. So this is implicit. It's happening. We don't really always think about that it's happening, okay? On the right here, we have explicit casting, where you can see we put it in parentheses, okay, and a data type right next to what we want to cast. So here we say, we want to make this 4.5 an int. So it's going to handle getting rid of this 0.5 right here, making it just a 4. Now, if we didn't do this, it might have been implicitly casted to keep this, to make this 3 a double. Okay, so when you rely on implicit casting, it's going to go a certain way. So we need explicit casting if we want to change something specifically where it's not going to happen implicitly. Okay. Now what these are really, really good for is casting with chars. So here you can see we make a char A, and we set it equal to A in single quotes and print it out. Okay. But a lot of people don't realize that when we're working with characters, they're actually really stored as integers. Okay, you might have heard of ASCII. Now, if you Google ASCII, you're going to get all sorts of wonderful charts that show, the integer value that maps to a specific character. So if memory serves, a lowercase a is going to give you a 97 as an int. So if I cast this char to be an int, it should print out 97, okay? And I believe a capital A would be 65. And there's a whole bunch of others, even down to doing specific actions on a computer for ASCII values. And so when I think of when is this important, like why would it be important to take a char and get its integer value? And if you think about it, we can start to shift that letter. So if A is a 97 and I add 5 to it and make it, 102, it's going to now be a different character. So this is what I think really good for encryption, changing character values by using the numbers as opposed to using the char value. But let's dive in and let's see an example of what that would look like. So let's focus on those 3 things that we just learned. So we learned implicit casting, right? So let's just print it out. So let's use our cout and do a 3 plus 4.5 and then our endl. And let's see which way it casts to. So let me compile, run, and we can see 7.5, right? So we had an int, we had a double, right? You can even see that there when I highlighted over it. Double, let's see if it shows it as an int. Oh, well, it shows the expression as a double, right? Because it knows to implicitly cast it. But let's say I want to now make this print out a 7. I want to explicitly cast that, which would really be the next part. Let's put that down here. And then let's let it be kind of known that that's what's happening. Now, casting, especially implicit casting, is where a lot of errors tend to happen because people expect the behavior to go a certain way and it doesn't. And so when the implicit cast does not work out the way you want, that's where the explicit cast is very, very helpful. So let's give this a run and we should get the 7 printed out, right? So we can kind of choose the direction we want this to head. Now with chars, this is particularly fun. Okay, so we have a char and let's just print it out, confirm that we see a number, okay? let's run this. We see the A. Everything's good there, okay? Let's print it out again, but let's explicitly cast it to be an int. We got to put it like that, okay? Now, keep in mind, we're focusing on ints, doubles, and chars. Those are the kind of the main focus here, but we can do a lot of different type of casting. I just am finding these to be the most important ones to do right now. And you can see that 97 printed out, exactly what it should be, okay? Now let's use our compound assignment. So why don't we go a plus equals, let's just do 10. And I know this is a char, okay? I know that's a char. I'm adding an int to it. And then without casting it, right? Because that explicit cast only lasts a single line. It does not change a forever. It's just gonna be right here, okay? So this should give me a character, right? But it shouldn't give me the same one anymore. And we see K now, right? Because that's 10 spaces away. And let's say, let me see if I can get us to the capital A, right? So let me minus, what, 25, 26, 26. Nope, way off. Okay, I forgot to take into consideration other characters. Okay, but long story short, we can adjust chars with ints, and that to me is really, really powerful, especially for encryption. If you look up things like the Caesar cipher, and I think it's called the Vajiri cipher, they rotate characters based off numeric values to change them. And it's, one of the earliest forms of encryption. It's a really good starting place if you want to see kind of how we can explicitly cast chars for a very good reason. All right, we've been working with strings this whole time, okay? But it hasn't always been this clear, right? I've always said like, hey, strings go in double quotes. I've been holding them off because they're not primitives, okay? So you can see right here, this is not a primitive data type. Primitives represent the most basic data, a number, a character. This is multiple char primitives stringed together, hence the word strings, right? So there's many different ways to string these together, but that's, hence the name string, right? It is a bunch of characters, all right? So we have a single char, single char, single char, single char. All these are primitives, but when we bring them together, this is no longer primitive because we're not talking about a basic piece of data. It's starting to get much more complex. Now, what makes C++ really hard is its compatibility with C. And C treats strings very, very differently, okay? And we're gonna need to dive a little bit into that into the future. Right now, I'm just gonna hit you with a definition and don't worry too much about C strings yet. But a C-style string represents words as an array of characters that are null terminated, okay? And that would be like an escape sequence 0 is null terminated. It's an older method of how we would differentiate pieces of data, right? So like the end of data used to use null terminated signals. C++ does things a little bit differently, but for compatibility, you will need to know this in the future, and we will talk about them in the future. But we are going to use C++ style strings, which are a sequence of characters that also have built-in methods because strings are an object, which is a class made for them. Now, objects is going to be a huge conversation for us going forward, not so much yet. Okay, so don't worry too much if you don't know what I mean by an object. But the big thing you should be cluing on here is these words array and sequence. These are different for a reason. An array is a data structure that we will be talking about this year. Very, very important data structure, okay? But when you kind of get to arrays, you start to realize, oh, that's how we made strings. And then lastly, a vocab word, string literal, a sequence of characters between quotation marks. Basically, it's like a raw string. Not the computer science version of a raw string, but it's a raw string. It's like, here's the actual value, okay? That's a string literal. So this hello world is a string literal. When I store hello world in a variable, we don't call the variable a string literal, we call this piece the string literal. Now, the cool thing about strings is, well, not the cool thing, sorry. Thinking of the next slide. What you're starting to notice is that things are getting conflated, right? Start to look at all of these namespaces being used. And you gotta been thinking to yourself at this point, like, man, These are annoying, okay? And if you think about some of the code we've done in the past with ASCII art, they're everywhere, right? And it's the same thing with string. String comes from the standard namespace, right? So the next slide, we're going to introduce how we can get rid of these. But on this slide, you have to do a couple things to make a string. For starters, you need to include the string header, okay? Now, just like the IO string, you need this. However, if you leave it out, you might find that strings still work, but don't leave it out. There's some built-in functionality that I think is super important to have. So include the string always when working with strings, okay? And we make strings like we do any primitive, right? We put the actual value we want on the right, a semicolon, assignment operator, we give the variable a name, but we also have to call the type right here, just like you would put an int, a double, a bool, a float. Now we have to put the standard name-based string, okay? Now what we're gonna introduce now is using namespace. And this is super helpful. And I haven't introduced it up until this point because I really want you to see why we did things the way that we did, okay? Where they came from. That when you were using certain pieces, they came from the standard library. It's important to know that. But it's also important to see how in coding, when we get sick of things, we make changes to them the way we want to. So some programmer got super tired of entering an STD every single time I wanted to call something. He's like, hey man, what if we had namespaces? Or you just put everything in a namespace. And then, we knew how to find where it was, right? So using namespace followed by the name of the namespace allows us to skip entering this in before anything from the standard namespace. Okay, so look at this code now. Notice how STD is gone, and so is the scope operator. Cout is much cleaner. Endl, much cleaner, okay? But you need to write this piece in order to get that functionality, okay? So using namespace and then the name of the namespace, okay? If you put that in your code, you will finally not have to type in all that extras. So let's dive in to see what this would look like. So let's do it without the namespaces first. So we would have to enter in the namespace and then say string, okay? Because this is an object, it's a class written. I know you won't know what that means right now, but in the future you will. Okay, and I'm going to give it a name. I'm just going to say hello world. And whoa, I don't know what I'm doing there. Okay, and then we're going to print it out to the screen. So cout, and we just send the name, and then we'll clear the buffer. Okay, let's give this a compile. And we see hello world, kind of as if we just would have put it right there. Okay. Now the beauty of those namespaces is using namespace. Whoa. We enter in the name, and now I can just go ahead and delete these and get just much cleaner, easier code to write. So let me save, recompile, give it a run, and everything still works, right? Let's comment this out and let's see what would have happened. Okay, so I comment that out, run it again, and look, it won't even compile. We see a ton of errors here, okay, because it just doesn't know how to find the things. But it's kind of starting to tell you right here, like, hey, I think you wanted me to use this, but we can't be too sure, okay? So you need to make sure you include that, all right? But it's very helpful to do this. It's really going to clean up our code, all right? The next thing we're covering is string concatenations. This is where we're able to combine strings together, okay? Now this is where those C-style strings get super tricky. When you make a string literal, it is gonna be a lot like a C-style string. Once you save that string literal into a variable, only then is it a C++ style string, because we need that string class to make it a C++ style string. Now, string concatenation is where we're going to combine strings together. Okay, so you can see this is the first method, or this is the method here that's valid. Okay, we created two variables. We wanted to put them together, right? So we just wanted to make hello world again, and for multiple pieces. So I have the hello variable, then I have a string literal, and then I have a variable here. Okay, this works just fine. And now this new variable hello world, is going to have hello comma world. The problem that's going to happen from this is when you try to only put string literals. That would make them only C style strings, excuse me. C style strings do not support this version of concatenation. They have you have to use specific methods to concatenate strings in C style strings. The way to get around this is you just need at least one C++ style string right here, and then the whole line can be mixed with them. So as long as you have one variable, you can concatenate with the plus operator, okay? But if you don't have any of them, this will not work. This will fail at compile time. So this isn't the only way to concatenate strings. There's a lot of other ways to concatenate strings, and we're going to talk about a lot of those ways. But for now, this is the easiest, okay? Easiest to remember. Also very intuitive, right? Like I'm adding these things together. But just be very, very careful that you need to have a single variable in order for it to work. Now, the next thing we're going to be going over is how do we check or checking user inputted strings, right? So in the previous lessons, we've gone over how to do it with a number, right? Or how to check if what they entered is greater than this. But a lot of the times the user enters in like a yes, a no, a sentence. So the good news is it works, almost identically, right? We need a string variable. We need to, ask them a question, and notice how now I'm writing my code without the std right there, so that we know, because this would be assuming that we're using namespace, because we know that now. And then we use cin to store it into the appropriately data type variable. Now for brevity, I didn't include the data type check. You would still want to do that, okay? But we can use the == operator to check equality, right? To see if name, whatever the user entered here, because that's what we sort of name, is the same thing as Michael. If it is, it would print out you got it right. If it wasn't, hey, that's not my name, okay? Now what's crucial about this is these strings are case sensitive. This capital M is much different than a lowercase m. So if I entered in the wrong case, I'd enter Michael with the lowercase m, or spelled it differently, it would, mark this up as false. And that's where things can get pretty tricky about checking strings. And then another note here is you can also use the exclamation equal to check if a string is not equal to another string. Okay, let's see what it looks like. Okay, so we are gonna do both of those at the same time. Okay, so we're gonna ask, we don't need that anymore. We're gonna ask the user to, enter your first and last name, okay? And we're gonna store it twice. So, cin, let me create these strings up top. So string, f name for first name, L name for last. I didn't give them, any initial types. They default to empty strings. And then, we'll see into the f name, and then we'll see into the L name, okay? So the user at this point should be able to enter in both their first and their last name, okay? Now what we're gonna do here is we're going to just concatenate these together, right? So let's just print that out. We don't need to store it into another variable. Let's just go f name plus, and let's put a space, okay? This is kind of crucial, something beginners kind of forget. They think there's just gonna be a space there because there should be a space between the first and last name. But if we don't do it in coding, it's not gonna happen. So f name plus a space plus the L name, and let's give that a run. Okay, what did I do here? What's going on? Okay. So, it's a little bit of my old Java days, is the capital S. Okay, so that's an error. In Java, we do a capital S for string. In C++, it's a lowercase s. All right, so enter your first name. Let's do, Ryan Reynolds. And it prints out Ryan Reynolds. So that's kind of the good thing of concatenating strings, is we can take in things separately, keep them separate, but then concatenate them together whenever we need them together, okay? Or we can concatenate these together to make another string called full name, and then we can have all three of them separately, okay? Now, kind of carrying off the back of that, all right, let's go and, let's do some if statements with this. Check if it was certain things. So if, fname, let's go like this. If fname equals lname, right? Which most likely shouldn't happen, but you never know. Interesting. I've never met anyone, their first and last name the same. But hey, it's first time for everything. Okay. And then let's keep doing some more checks. Okay. Always make sure to use those else ifs too if you only want one thing to print out, right? If you do a bunch of ifs that are separate, they will all be checked, and we really want to use our short circuit evaluation. So else if, if fname is equal to, Ryan. And notice how there I'm using the string literal, right? I'm not comparing two variables, which is also possible. You can compare two variables. I'm just comparing a variable with a literal, which is totally fine to do. Okay. And so then let's print that out. Oh, your name is Ryan. That's cool. Okay. All right, let's save this. Let's see if we are hitting the mark. Okay, so let's go Ryan and Ryan, and we can see that they were equal to each other. But let's change the case. So let's do a capital R and a lowercase r, and see how it says, oh, your name is Ryan. So it's still checked fname, right? Because this was false, and so then this one ran, and the first one was capital. So it's okay that this one ran, right? But we saw that this one didn't run. Even though you and I can tell that these are the same, they're different to a computer, okay? Postpone. Okay, now all of this is looking pretty good. Okay, so this is all working. We can just check the same way we would with a primitive, all right? Now, the last thing I want to show you here is that concatenating strings with only literals, okay? So let's say I, make a variable, string name equals just name. Let's just keep it simple, okay? And then I want to add, let's see. Then I want to add in, let's do this. Let's not plus equals. Let's do this differently, okay? Let's just go name plus me plus hi, okay? All these are just super random, and that's fine, okay? 3 literals, we're trying to store them into a variable. This should fail at compile time, right? Because those are C strings. Notice that says constant chars, okay? And these are char arrays. That's the C string style array, right? This is not gonna work. But if I just drop in one C++ style, this should work. See how it compiles? And it doesn't even have to be the first one. Let me go back. I can put just a 4th one at the end there. Okay. And it compiles fine as long as there's one variable. Okay. And this actually brought up something that I think is important that I should have mentioned. Let's create the string full name. Okay. And let's use the compound assignment. Okay. So full name plus equals, okay, fname, and then let's print it out. All right, and then let's go full name plus equals lname, okay, and let's print out full name again. All right, this is something that's really cool. You cannot use too many of these compound assignments. In fact, I'm pretty sure the only one you can use unless you overload those operators is the plus equals, okay? So remember, plus equals is going to take this one, add it with this one, and then store it back in this one, okay? So let's see what happens. Let's recompile. What do we got here? Interesting. Let's see what's going on. Whoa. All right, let's get all that back. So, sorry, I'm used to using a Mac, and this is Linux, so it's different keys, okay? So let's give that a run. Ah, that did fail. Interesting. So when I tried this on a Mac, it worked. When I'm using this on a Linux, it didn't work. So that's another interesting part about using C++ is using a different compiler, using GCC as opposed to using Clang might yield different results. Okay, so this is something you're going to have to play with a little bit here. All right, maybe you should try and make sure that it's always the first one first. Okay, and what I mean by that is that the C++ string is first, and then those are after. Okay, it seems that it's better to have this early on. Okay, now what you see here is some errors happening, right? This is normal in coding. Okay, you are not going to be able to know every single possible thing that you could about coding, and that's all right. When you make errors, which you will in every program that you write, you need to go with the flow. You need to debug, try and figure out those errors. Okay, so that's why I'm not going to take that out of the video. I want you to see me trying to make changes, see me incurring errors and dealing with them, because that's what coders need to do. Okay, so let's see if this runs now. Okay, so let's enter Ryan Reynolds again. And look at this. They did squish together at the very end there. Okay, notice how there was no space. So let's put that space in. Let's put it right here. Okay, so then these should be added together, and then it'll go to full name. And maybe we might run into another error here again because I put the C style first, which was the literal, and then I put the C++ second. Maybe it does need to always be the first one. Ah, interesting. Okay. So that's interesting behavior there. Okay. Maybe it has to do with something of how long that I did this. Okay, maybe it's because I had 3 and it could be the second one and that's okay. Very interesting behavior. But for now, always make sure that you have 1 in there. Okay. All right. Okay, here we have complicated C++ string initialization. I really liked the lesson I did the complicated C++ with. And the reason why I really liked it is so many people are afraid of C++ because of its flexibility for so many ways to do the same thing, okay? And string initialization is one of those things. Here are 6 valid lines of code that make a string in a completely different way, okay? So here, look, string A. It's defaulting to an empty. We didn't put an initializer, but the compiler will initialize it to be empty, okay? Here we did it the way that I showed you. String B equals hello, right? With the string literal. This is called copy initialization. It's not so important to know what copy initialization is right now, but if you're ever looking it up, that's what this is called. This one right here, I believe, is called direct initialization. And you can notice it's very different, right? There's no equal sign. I put parentheses right here, okay? And then this one, I'm just using a previous string, and this is also copy initialization over to make D a separate string, but that was equal to B, which would be hello. Then I'm doing that direct initialization, but using a previous string. And then this one's super weird, right? So string, and I'm making the character F, and what I'm saying with this is if I pass this number and a character, it's gonna do 10 A's into the string. So now I have a string with 10 A's, which might seem trivial, okay? And I'm sure there's a reason where this line of code at the very end here is the most important line of code that was ever written, okay? But it's not always. So don't frustrate yourself by trying to remember everything. It's good to see it. It's definitely good to see it because when you go online and you look at other people code, they like to do different things, and that's okay to do that. But I'm going to be using this one. Okay, this one's the clearest, it's the cleanest, it's the most similar to how you would do it with a primitive. And maybe sometimes I might do these other ones if they're important, okay? Stick with this and then only use those if you have to, okay? And in fact, this might be the weirdest time to mention this, but there's entire competitions to make the most obfuscated C and C++ code ever. To make code that looks so confusing, but does like very simple tasks. Okay, don't get bogged down in all that. Do the simple ones unless you have to, for some reason you didn't have to. Okay, now if you look at this is actually really cool. It looks like I'm just cutting it off this whole thing because I'm printing out the A, B, C, D, and E, right? This is totally valid to do this. If you're running over, C++ ignores white space, so I can carry on as long as I don't carry on mid-literal. I need to make sure I finish a literal, on the previous line, finish something. I don't want to be mid-expression down, okay, if I want to use multiple lines. And I'll show you that, I believe, in a little bit, okay? Now, the last thing is you have a quick code, okay? And this quick code is not a simple calculator. That is an error, which I will change. You need to create a program that asks the user to enter yes, no, or maybe. If they enter yes, no, or maybe, print out that result. But you need to build into your program every variation of those answers, or at least every single one you can possibly think of. And here's what I mean by that. If someone asks you a yes or no question, they could respond with a yeah, right? And make sure your program can check against those. So, if you ask me, did I have a good day today? I could say yes, yeah, sure. And there's probably 10 more that I could think of. I want your program to take those into consideration, and even a couple different capitalizations. Let's say minimum of 5 different types of yeses. Okay, but I would go further than that. And then a minimum, 5 different types of no's and 5 different types of maybes. Okay. Now this seems like a simple quick code. It is a simple quick code. But I want to get you guys used to thinking in C++. Okay. Now, we are going to do a quick code example. I think this is going to be helpful. I'm going to show you what the output of that code should look like so that you feel a little bit better when looking at yours and make sure that it's the right thing. All right, so here's an example of what your quick code should look like, right? So here you're asking them, do they have a good day? I'm going to say yes, right? So that worked. I'm glad you had a great day. Here, I'm going to run it again. And this time I'll say, yeah, sure I did, right? And it also gives me that same output. Now, here I'm going to run it again, and I'm just going to say, meh. And, I didn't recognize your answer. So having a built-in else for things that you don't recognize. But I want you to have 5 that work for yes, 5 that work for no, 5 that work for maybe, and keep it to still single words, right? Because if we start to get into expressions like, yeah, I'm having a good day, there could be a lot of variability there. So focus on single word answers. And if you do it right, this is kind of what your code should look like.